Hello all, welcome to the video on evaluating the postfix expressions. I'm SS Nalgund working with SDMCT Dharwad. In this video, let us try to have a very quick recap of how to convert given an infix expression into postfix form and then how to actually evaluate it. So if multiple operands are separated by an operator, we know that it is called an infix form. Infix form must be converted to postfix form or postfix expression for the ease of evaluating it. Here is an example. 3 plus 4 star 5 slash 6 gets converted as the one shown here. Now this is done by employing stack operations like push and pop very intelligently. By following a sequence of steps, we will be able to complete the conversion of infix expression into a postfix expression. One more example is shown here on your slide. So the ultimate goal of this particular presentation is that when a postfix expression is given, how do we evaluate it and get the answer? To put the things into perspective, we have an infix expression which gets converted into a postfix expression, and this postfix expression must be evaluated to find the final answer. Let us consider a very simple example and understand the concept. Let me start off with postfix expression itself. Let's assume that the expression given to us is a, b followed by the plus operator. So what we do is we look at each and every incoming character. The incoming character can be either an operand or operator, and we try to process them accordingly. The first incoming character is an operand, so it gets directly pushed onto the stack. The second incoming character is once again an operand that also gets pushed onto the stack. So the top of stack consists of the data B, which is followed by A. When I encounter the operator, what we do is we try to perform two pop operations. The first pop operation gets me B, the second pop operation gets me A. So A plus B is done and the answer is once again available on the stack. This is a very simple procedure to evaluate postfix expressions. Let us consider one more example. Given the infix form, it is converted into postfix form as shown here, and we try to look at individual tokens. The first token or incoming character is an operand, hence it is directly pushed onto the stack. The second incoming token is an operand that is also pushed onto the stack. The third input character is also an operand, so that is also pushed onto the stack. So it's very important for us to know that the stack can consist of not just two operands, but it can consist of many number of operands depending on the form of postfix expression. Once I encounter the next character, which is star operator, then what we do is we perform the first pop operation that gets us 5. Second pop operation gets us 4. So 4 times 5 is done to give an answer of 20. Now this answer is once again pushed back onto the stack. So right now the top of stack consists of the data 20. Next, the incoming character is plus operator. Once again I perform the first pop operation to get me the data 20, and the second pop operation gets me the data 3. So 3 plus 20 is done and the answer is 23. Now this answer is once again available on the stack itself. So this is how we actually evaluate postfix expressions. Here is one more example. 10, 2, 8 star plus 3 minus. So the incoming character is 10, directly it gets pushed onto the stack. 2 gets pushed onto the stack as usual. 8, same thing. Then there is a star symbol. So what happens is when I have a star operator, two pop operations I want to perform, so I'll be able to get the data 8 and 2. So 2 star 8 is done to get the answer as 16, and this value is once again pushed back onto the stack. The new incoming character is a plus symbol, so 2 pops get me 10 and 16, and I add both of them to get the answer as 26. Now this is once again pushed back onto the stack. The incoming character is 3, it is pushed back onto the stack, so the content of stack is 26 followed by 3. The last incoming character is a minus operator, so we perform 2 pop operations. It's very important for you to realize that it is not 3 minus 26 which is being done, it is 26 minus 3. Now 26 is the result of second pop operation, so that becomes operand number 1, and 3 is the result of first pop operation, that becomes operand number 2, and hence we get 23 as the answer, which is stored back on the stack once again. So this is how we evaluate the given postfix expression. So this is a simple algorithm to understand the same procedure. It's well known that RPN stands for reverse polish notation. This is another name for the postfix expressions. So initially we start off with an empty stack. We repeat the following procedure until the end of the expression. We look at individual tokens. The tokens can be a constant or variable and operator. Now if the token is an operand, then we push it onto the stack. If it is an operand, then what we do is we try to do the following 3 steps. We, as I told you before, pop off 2 operands from the stack and then apply the operator to these 2 values and push the result back onto the stack once again. Now when the end of expression is encountered, the value is available on the stack itself. Let us look at one more example. This is the given postfix form, and the numbers are 6, 2, 3, plus, minus, and so on and so forth. So please try to trace the execution of this postfix expression. 6, 2, 3 onto the stack. Incoming character is plus, so 2 and 3 are popped off, they're added together, and the answer is pushed back onto the stack. The new incoming character is minus operator, so 6 minus 5 is done, and the result is once again stored onto the stack. The incoming character is 3, it is placed on the stack. The new character 8 is also stored. Then once again the new incoming character, a data value of 2, is also pushed onto the stack. When I encounter the slash symbol, then what I do is I perform 2 pop operations. So it is 8/2 which is done, and the result is once again stored back onto the stack. So the content of stack right now is 1, 3, and 4. Similarly, when I encounter plus symbol, I perform 2 pop operations. So 3 plus 4 is done, and the result is available on the stack as usual. For the next star operation, 1*7 is done, and then the answer is 7, which is pushed back onto the stack. The new incoming character is an operand 2, so that gets directly placed on the stack. Now we have an operator which is exponential operator, so I perform 2 pop operations. Please understand that it is 7*2 that is done and not 2*7. So the second pop gets me the first operand, and the first pop gets me the second operand in order of evaluation. So 7^2 gets me 49, which is available on the stack. The same thing is true for the remaining operator as well. So when I encounter plus symbol, I perform 2 pops, and then 49 is added with 3 to get me the answer as 52. Let us consider a simple example of $823/2 plus. Now this is directly starting off with the postfix expression, and please work your way through and see if the answer you obtain is 7. Another example for exercise: 100, 200 plus 2/5*7 plus. Please work your way through it and see if you can get the answer as 757. Hope this video was of some use to you. So if it has helped you, please comment in the comment section and subscribe to the channel. Thank you so much.